Welcome to The Explainer. Today, we're not just talking about generic health tips. We are going to uncover the hidden biological operating system of human sleep. I want you to imagine your bedroom not merely as a room with a mattress and some pillows, but as a dynamic, tightly sealed biological chamber. Every single night, you enter this chamber expecting deep, restorative sleep, the exact kind of sleep that dictates your cognitive resilience, your metabolic health, and your emotional regulation for the following day. But for so many of us, that vital recovery is being sabotaged by a completely invisible force. So, we're going to decode this mystery, looking way past the myths of interior design to investigate the actual neurophysiology and botany that govern your nighttime environment.
Okay, let's dive into this. Why do you always wake up at 3 a.m.? It's literally one of the most common, frustrating symptoms of modern life. You probably blame stress, your diet, or a weird dream. But what if the answer isn't psychological at all? What if this symptom is actually a profound biological clue? To really understand this, we need to zoom in on the physical environment of the modern, energy-efficient bedroom. We seal our windows, we shut our doors, and we essentially trap ourselves inside an invisible, airtight ecosystem.
Section 1. The Invisible Sleep Thief. Think about it. Your bedroom is a closed ecosystem, and you are its primary engine. As you sleep, you're continuously exchanging gases with your environment. Now, outdoors, atmospheric CO2 hovers right around 425 parts per million. But indoors, in an unventilated bedroom, human exhalation causes ambient CO2 to rise incredibly fast. By the early morning hours, that concentration frequently spikes to 2,000 or even 3,000 parts per million. You aren't just resting, you are slowly altering the chemical composition of the air you desperately need for recovery. And this brilliantly illustrates the exact physiological domino effect that happens next. You see, your central and peripheral chemoreceptors are continuously monitoring your blood gases. When that ambient CO2 rises, these receptors sound a massive biological alarm. To clear the gas out, your respiration rate increases and your heart rate accelerates. Your nervous system actually shifts into a mild stress state, which literally fractures your restorative, slow-wave deep sleep and triggers those subconscious micro-awakenings right around 3 or 4 a.m.
The consequences here are severe. When you're exposed to 3,000 parts per million of CO2, your sleep quality plummets to just 80.8% of its normal baseline. You're losing nearly a fifth of your restorative recovery. Over time, this compounding loss seriously impairs your metabolic health and cognitive resilience. It's like your biological operating system is crashing simply because it lacks the most basic chemical requirement to run: fresh air.
Section 2. The Great Houseplant Myth.
For decades, we've tried to fix indoor air pollution with a wildly popular biological band-aid: houseplants. This belief traces all the way back to a highly publicized 1989 NASA study that was looking into air filtration for space habitats. NASA placed plants inside these tiny, perfectly airtight glass chambers, injected chemicals, and watched the concentrations decay. And sure, in that sealed 1 cubic meter microcosm, the plants worked. But your bedroom isn't a tiny glass box floating in space.
So the crucial point is what happens in the real world. In a massive 2019 meta-analysis, Drexel University researchers analyzed decades of plant data and absolutely shattered this myth. They conclusively found that potted plants simply do not improve indoor air quality in dynamic human environments. The natural microscopic drafts that are already happening in a building dilute air pollution drastically faster than any standard plant could ever extract it.
Just to put this into perspective, researchers calculated that to match the air exchange of merely opening a couple of windows, you would need to densely pack between 10 and 1,000 plants per square meter of floor space. Unless you plan on sleeping on the floor of a dense, humid rainforest, a couple of potted ferns in the corner are doing virtually nothing to scrub your air.
Section 3. The Nighttime Oxygen Paradox.
So if standard plants aren't cleaning the air, what exactly are they doing in the dark? Well, the truth exposes a crazy nighttime paradox. Most common houseplants are C3 plants. During the day, they photosynthesize, releasing oxygen. That's great. But at night, photosynthesis completely stops, and the plant undergoes respiration. It actually absorbs oxygen and releases carbon dioxide back into your room, actively competing with you while you sleep. But evolution has provided a fascinating exception. Now, what's really interesting about this mechanism is a biological marvel known as crassulacean acid metabolism, or CAM for short. Plants from harsh, arid environments, like succulents, keep their pores, or stomata, tightly closed during the scorching day to prevent water loss. But when the cool night arrives, CAM plants finally open up to capture carbon dioxide, simultaneously releasing the oxygen they produced internally during the day. They flawlessly complement human nocturnal biology, absorbing the gas we expel while releasing the exact oxygen we need.
Section 4. Engineering the sleep sanctuary.
It's time to shift from understanding the problem to actually executing the blueprint. If you want botanical allies in your bedroom, you have to select them with scientific precision. We need to clearly delineate the bio-optimizers from the false friends. Safe, nighttime oxygen-releasing CAM plants include the snake plant, aloe vera, and the highly resilient spider plant. On the other side, we have highly toxic, heavily marketed plants like English ivy, true lilies, and the sago palm. We must impartially assess the risks of these indoor cultivars, because bringing biology into your home has real consequences. True lilies carry unidentified systemic nephrotoxins that cause severe acute kidney injury in cats. The sago palm contains psychosin, which can lead to acute liver failure, and English ivy is particularly deceptive. While some small lab container tests showed ivy could reduce airborne mold spores, in a real home it does not fix the moisture problems actually causing the mold. Furthermore, it contains toxic saponins that cause severe gastrointestinal distress and contact dermatitis in humans and pets. The lab benefit simply does not outweigh the real-world toxicological risk.
Let's see how this all builds into the ultimate operating manual for your sleep sanctuary. Step 1 is the absolute foundation, mechanical ventilation. Keep a window slightly cracked to run a high-quality HVAC system to dilute that human-generated CO2. Step 2. Make the invisible visible by using a non-dispersive infrared CO2 monitor like the RNet 4. And Step 3, supplement this optimized airflow by strategically placing safe cam plants like snake plants to gently boost your nocturnal oxygen.
We've moved from the frustration of a 3 a.m. wake-up to the profound realization that your bedroom is a living, breathing ecosystem. You now possess the biological blueprint to control it. You know exactly why the air gets stale, which plants work against you, and how to engineer a space designed for maximum human recovery. The hidden mechanisms are no longer hidden. So, the final question is, now that you understand the invisible operating system of your biology, how will you choose to sleep tonight?